The first method we have for displaying data is going to be frequency tables. Now, the reason frequency tables are so useful is they can be used with quantitative or categorical variables. So frequency tables consist of 4 different columns. The first column is for observations. This is the things people tell us. This could be the number, this could be the color of your eyes, so your observation goes on the left. Then the count, that's also called the frequency, how many times people give us those answers, proportion, and then percentage. Notice we have totals down at the bottom as well, and we'll talk about kind of how we find those. Now, to begin here, notice that we're looking, first of all, for people who told us that they ate out 1 time per week. And so to get the count for that, all we're going to do is we're going to come up to the top here and count how many people told us 1. So if you look up here, there are, I believe, 5 ones. So the count for 1 will be 5. Now, at this point, I want you to go ahead and pause it and fill in the count for each of the rest of them. Now, hopefully we've gone ahead and gotten the same numbers here. So you have 5 ones. I found I have 11 twos. I have 8 threes. I have 3 fours, 1 6, and 2 10s. And the reason we have the total at the bottom there is because now we need to know how many total people answered us. That is, in this calculus class, how many people did we have? To get that, we just go ahead and add down. So 5 plus 11 plus 8 plus 3 plus 1 plus 2. And I believe we have a total of 30 different people. Now that's important because the next thing we want to do is calculate the proportion. That is, yeah, it's awesome that 5 people ate out once, but really, is 5 a big number? Is it a small number? That is, how big is 5 with respect to the entire class size? This is what proportion tells us. It's also called the relative frequency. That is, how frequent it is relative to the overall sample size. To find the proportion, we just take the count and divide it by the total. So this is 5 out of 30 people told us that answer. Proportion for the next one would be 11 out of 30, 8 out of 30, 3 out of 30, 1 out of 30, and 2 out of 30. Now the key here is that the proportion should add up to 1. That is, if I take 5 over 30 plus 11 out of 30 plus 8 out of 30 and so forth, this should add up to 1. Now, a lot of times when we do proportions, we don't want to give it in fraction form, but actually in decimal form. And so if I wanted to do that, I could go ahead and take this 5 and divide it by 30. Take the 11, divide by 30, the 8 divide by 30, the 3 divide by 30, and so forth. And instead of writing the actual decimal there, the actual fraction there, I could write the decimal instead. So for instance, if I take 5 divided by 30, it's going to be 0.166. And for proportions, we're always going to keep 4 decimal places, so I would round that last 6 to a 7. Here I could write 0.3667, 0.2667.1, it's kind of a nice one, 0.0333, and 0.0667 there. And once again, the only thing I did to get those proportions in that form is take 5 divided by 30, or 11 divided by 30, or 8 divided by 30. So actually just convert it to a decimal. Now the reason this is useful is because the next thing we want to do is find the percentage. And to convert a proportion to a percent, all I'm going to do is I'm going to take the proportion and multiply it by 100. And so that's why that decimal is useful. So I'll take 0.1667, convert it to a percent, 16.67%. 36.67%, and so forth. Now, ideally, these percentages should add up to 100. I want to be clear, though, sometimes these aren't going to add up so nicely. That is, the proportion might add up to like 0.99, or the percentage might add up to 99.97%. It's just going to do a lot with our rounding. So it's okay if it doesn't add up perfectly, but this is our general form for a frequency table. A contingency table is a lot like a frequency table in that it allows us to display how many fall into each category. The difference is a contingency table accounts for 2 different variables. So for instance here, you can see I have the type of animal and the animal's sex. Now, I'll go ahead and give you a second. I want you to go ahead and read through the problem, ignore my alternative spelling of Baltimore there, and then click play once you're done. Now, to fill out a contingency table, the most important part to remember is that it's additive. That is, our row here, number of cats, must add up to the total number of cats, or the number of dogs must add up to the total number of dogs. That is, our rows or our columns will always add up. Now we're going to start here at the very top, which says the society had 14 dogs. To understand where this is going, we're going to go ahead and look at the dog row. And this isn't male or female dogs, this is total dogs. So I'm going to go ahead and look where total hits dogs, and that's where that number will go. So, once again, I have a total of 14 dogs. Now, out of those dogs, 6 of them were male. There we go, a little bit better. Now, if I have 6 dogs that were male, that means I'm going back to the dog row here. And I'm going to look over where dog hits male, and I'm going to put 6. That is, I have a total of 6 male dogs. The nice thing about this is it allows it, once again, to be additive. So if I have 14 total dogs and 6 male, I can get the female by taking 14 minus 6, which I believe is 8. So I have a total of 8 female dogs. And I got that once again, 14 total, 6 are male, the remainder has to be female here. Going on to the next sentence then, I can see that we have 27 cats. This is the total number of cats, so I'm going to go ahead and do cats and total. I will then put 27 there, a total of 27 cats. Out of the cats, 16 were female. So coming over here, cats and female, there are 16 of them. Now, if there were 16 cats that were female and 27 total, I can take 27 minus 16 to get 11, and that means 11 of my cats were male. The only other thing I have to do is go ahead and figure out my totals. So here I can tell I have 27 cats, 14 dogs. So if I add 27 to 14, I believe I get 41, and that's the total number of animals. I've got 11 male cats, 6 male dogs, so I've got a total of 17 male animals. And then I've got 16 female cats plus 8 female dogs, and adding those up there, I get 24. Once again, if everything works out, it should add. So I should be able to take this 24 down here, plus the 17, and get my 41. Now, stem and leaf plots are useful only in looking at quantitative variables, and specifically only with discrete ones. Remember, that means that there are only finitely many options. That's going to be important because we don't want to have infinitely many options as far as a stem and leaf. Now, when we go to do a stem and leaf, we go ahead and we draw a vertical line dividing. Now, to begin a stem and leaf, we draw a vertical axis. This is going to divide our stem off of our leaf. So over here is going to be our stem, and normally we wouldn't write this, and over here our leaf. The idea is that any number going into our stem and leaf will be split up into the stem and the smaller leaf coming off of it. So in general, any number going on a stem and leaf, let's look at the number 17, is going to be divided so that the last digit is the leaf and the rest of the number is the stem. So the number 17, for instance, would look like 1, 7. Now, it turns out that any number we want to put on here that has the same stem will go on the same line. So, for instance, number 19 would also go here. It's also got a stem of 1 and a leaf of 9. If we had another 19, it would go on there the same. So we would have 2 9s to represent the fact that we had 2 19s. If we had the number 20, it would go down here. It's got a new stem and a leaf of 0. We tend to put these in ascending order, that is, smaller number, smaller leaf on the inside, out to larger leaves on the outside. So, for instance, I could add in the number 21 by putting a 1 here, 22, and 28. Now, if a number goes into more digits, that's entirely fine. Let's say we hit the number 205. Once again, the leaf is only the last digit, so we'd divide it off, and we would put the 20 on this side and the 5 on that side. So let's go ahead and look at an example here. So this is our first example of a stem and leaf. Notice that all my numbers here have 3 digits. That's entirely fine. I'll still divide it off so there's only one number left in the leaf. Now when I look at these numbers here, I'm going to go ahead and try and arrange it so that I've got my smallest stem on top down to my largest stem on the bottom. The smallest stem will be right here, and I'll divide it off so that 19 is the stem. Looking across, the next number will have 19 as a stem as well. The next one will have a 20 stem. 20, 20, 21. And that looks perfect. Now I'm going to go ahead and add on the leaves. For the 19s, I have 19 with a 1 after it for 191. I have a 3 after it for 193. For the 200, I'll put a 0 here. I have a 204. I have another 204 as well. I have a 211, so 21, 1 for that, 21, 3, 21, 5, and 21, 5 again. So once again, the key here is we divide off the last number, that'll be the leaf on the right side, everything else will be the stem on the left side, and if we have repeats, that's fine, we just repeat that digit. Whenever we go to do our histogram, one of the most important things we're going to do in the very beginning is figure out how wide our intervals are going to be. So in this example here, I want you to go ahead and notice my interval runs from 10 to 15. As a reminder, this little bracket on this side is what we call the closed bracket. It means include that number. The parenthesis on the right-hand side means get really close but don't actually include it. So this first interval would include any number from 10 up to but not including 15, which would mean like 14.9 would work, 14.99 would work, but as soon as we hit 15, 15 is not going in that first interval, it's dropping down to the second. Now for each of these intervals, we need to figure out how many people fit into each one, or in this case, how many games had that high of a score. So for our first interval from 10 to 15, I notice I have 13 and 14, which means I have 2 games that have a score between 10 and 15. The next interval from 15 to 20, I can go ahead and run there. Notice it does not include 20 because of that parenthesis, so it looks like I have 4. My next one runs from 20 to 25. It does not include 25, so I'm going to go ahead and include 20, but stop before 25. Looks like I have 4 there as well. 25 to 30, I have 2. 30 to 35, I have 2. And 35 to 40, I have 2 again. So all I've done here is go ahead and what we call bin in the data. That is, I've taken my data and put it into little intervals and figured out how many fit into each of those intervals. The next thing I'm going to do is going to go ahead and create my histogram. Now to do this, we're going to zoom in a little bit on this bottom part. And I'm going to start by making myself a horizontal axis. That horizontal axis will have my intervals on it, and those will run on a number line. Now, as a reminder here, I started at 10 and ran by 5s, so I'll go ahead and start here. 10, 15, 20, and so forth. All the way up. On the left-hand side, we can put a vertical axis if we want to. A lot of times I will leave it off, but as this one is our first one, I'll go ahead and include it. This will be our count. Now, what I want you to notice is up here, I have 2, 4, 4, 2, 2, 2. My highest count is going to be 4. So I'll go ahead and I'll count by ones here. So we'll say 1, 2, 3, 4. So once again, this is count. And this is how many points we were dealing with. Now my first one has 2 games in it. So that first interval there is going to have a bar that's 2 tall. My next one is 4. My next one after that is 4 again. My next one after that, 2. My next one after that, 2. And my final one, 2 again. And so here we have our histogram of our point data, count on the left-hand side, points on the bottom, with width 5.